Hey, hi everyone. I'm going to keep crossing in front of my own projector. My talk today is on what's called data cleaning and exploratory data analysis using two tools that you might have been mentioned, you might have encountered earlier today. One is the Jupyter or maybe IPython notebook. If you were in the REPL-driven development talk, you would have seen him use IPython, which is the basis for this. Some other people have probably been using notebooks. And then Pandas is a library in Python that was made specifically for doing exploratory data analysis. Are you familiar with, raise your hand if you're familiar with data cleaning. And exploratory data analysis as opposed to regressions. Yeah. So I've worked, right now I'm a data engineer at Simple, and I've worked both as a data analyst, a data scientist, and a data engineer. And the reason I've been able to accomplish that is that there is meaningful overlap in the tasks required of each one of these roles. To the point where people make the joke, you know, what is a data scientist? It's a data analyst who works in Silicon Valley. So I'll give you a broad conceptual overview first. When you work as an engineer, analyst, or data scientist, probably what's going to happen is someone's going to say, I want a beautiful dashboard to present to my client to give me unique insights into data we've been collecting for a decade. And you're like, great. Where's the data? Oh, well, I have an Excel file. Or if you work with, I love working with civic data. I don't know, was anybody in Oswald's talk earlier today? It was beautiful. He developed the first Google Transit app integration for the Jamaica public bus system there. And he did that starting with Excel files. It was a nightmare. I mean, the Transit Authority was great, but that's often how data lives. I want to show you these two tools because they're uniquely excellent for exploration. This is very good for data analysis, but it's also really good for your code. A REPL provides that rapid feedback that we've seen a lot of keynotes mention earlier today, that you become a much better engineer when you see quickly how something should be improved. I'll walk you through the code now. This first section is just going to be features that I find especially useful in the Jupyter notebook. And once I've shown you a few of my favorite tips and tricks, I'm going to show you a couple of approaches that I've taken using Pandas to performing what's called exploratory data analysis. And I will go into what that kind of analysis is later. So this is my import statement. It doesn't actually require very much of you. I won't go into the rest of the tools here, but I can explain it later. Sometimes when I give this talk, it's to scientists, so I have a few comments here on why you want to do that. So we're all here probably because we value open source, or there's a meaningful overlap between people who value open source and Python. So Jupyter Notebook allows you to retrace your steps. It makes you a better programmer, but it also has this clever way of ensuring that the documentation you need is inside of the notebook, so you don't have to leave. One of those is, I don't remember the origin, but it's really common in Bash. Oops, that's Markdown. This was also converted to Markdown. Is that if I want to explore, let's say you're going to go through this soon, I hope. You install Pandas, you're really excited about it, and what does Pandas even do? And you can start saying, well, okay, I have Pandas and I know it can read stuff in, but what can it do? And you can tab complete to see all of the files that it's capable of reading in without having to go Google it somewhere else, which is kind of a pain, and context switching is costly. You can also do that to explore, what else is available in a library this way. It also has built-in documentation in the sense that if you have a command here, you can put a question mark at the beginning or the end, run this, and then a new window comes up showing you what your keyword arguments is and some doc strings, telling you not only what
arguments are, but say best practices. If you already have some sense of it, but you just want a quick reminder in the middle of writing your function, like what arguments you should be passing, you can just say Shift-Tab, and it shows you right there. What you might notice is that in this environment, I have both code as we know it and this nice markup. This is because there are different types of cell in the Jupyter notebook. You know, kind of like when people say, well, a unit test, it has like its own, maybe they'll tell you it should only be 10 lines, but a unit may also be something that particular to you, your idea of what makes sense to keep together. And so that's what I use a cell for. Each cell can only be one of several things. It can be code, like there, and you can use this, oh, ¿qué pasó? So I don't have to show you the drop down. We'll wait for the back. Nice. The different cells, I will touch it gently now, include code, markdown, raw. I'm not going to talk about heading right now because that's effectively just HTML headers, and we'll ignore that for now. This allows me to put. This allows me to include nicely rendered documentation with my code. So Donald Knuth, you know Donald Knuth, LaTeX, Art of Computer Programming, old school dude. He had this fantastic dream of literate programming, and I think it's arrived with Jupyter Notebook. It has beautiful documentation right alongside the code, and it can render not just Markdown, but HTML and LaTeX, which is great if you study math. Any math students here? Nice. I'm sorry. It's difficult. Okay. And it provides syntax highlighting for other languages. I'm going to see if I avoid the trackpad, it can stay there. And then, in addition to the Markdown and code, there is something called raw NB convert. So what I should have started with is that underlying the thing that you're seeing as this notebook, this nicely rendered document, is just JSON. Everybody knows JSON. Sorry, I never know what I'm taking for granted. Yeah, it's just JSON. It's ugly when it's JSON, but that means it's easily shareable among anybody you send it to. In fact, it's even rendered natively in GitHub now. It wasn't always so. Nice. So, for example, the cell above with the glitter text and all that is just this code. And you can also export that if you want to make sure that exactly what you're seeing here is exactly what's in the code. And this thing called magic methods. Quick ref is a way for you to, and now I've done it, I have to move the trackpad. Is a way for you to explore all of the ways that you can use magic methods. Because sometimes I like just looking through all of the potential commands I could use without having in mind in advance what exactly I'm trying to accomplish. Then another really beautiful magic method I like is just writing Python 2 to run that code inside of this notebook. So this is a Python 3 environment, but I can run Ruby or R or Python 2 within it if I need to. Clearly you don't want to have like application inception, but it's great for a snippet because some of the analysts I work with are still using Python 2, and that way we can still talk to each other. And then this is much like Bash has. I'm sure nobody here does it, but I sometimes write code at like 2 o'clock in the morning, and I've done 1,000 things before I wind up with what I need, and I don't remember what I've done. This environment is saving all of it for you too. And it's all this thing, it's called magic method because Jupyter has done some work to predict what you're going to need to do a lot so that you don't have to bake in, or they bake in what you're doing so that you don't have to come up with everything from scratch. And here's just a thing that you can use to see, again, LS with magics. Multimedia, which I am not allowed to use on, oh, nice, okay. This is a great machine learning talk that you can embed into the notebook too. So I've used that for teaching. And like I said earlier, yeah, the sharing is very easy because its underlying format is JSON. And then, as you may already have intuited, if you just prepend an exclamation point to a bash command here, you can run it. And so I do that sometimes when I don't want to change contexts. And then keyboard shortcuts. It already has a lot of keyboard shortcuts such that, for example, if you're trying to give a presentation and every time you touch your trackpad it breaks, you can use keyboard shortcuts to navigate instead. You can also create your own. So that was a quick overview of tips that I like to use for Jupyter. It wasn't a comprehensive, beginning to end, because you're going to be able to discover that yourself, but there are a few things that maybe an introductory tutorial might not show you before. It's just things that I know have made my job faster. So now I'm transitioning to talking about exploratory data analysis with Pandas. I'm going to go over 2 data sets with slightly different techniques so you can see the contrast. What we call exploratory data analysis is, as I said, part of my job, irrespective of the name of the role I've had. Because, for example, if I need to do like a Redshift backfill, I may need to have some idea of the structure or contents of the data I'm supposed to be working with before I move it over. And I don't want to be too invested in the initial way I do that. It's a big mess. You can think of this as like a sandbox. So exploratory data analysis is part of all of that. Before we start doing something really sophisticated with machine learning, let's just make sure we know what the range of values we should expect is and the like. So the first is United States income data. That's available openly through the IRS. Do you also have location-based income data for the Dominican Republic?
No, I don't. Well, maybe it exists, but I'm not sure.
Okay, yeah. I was wondering how unique that is, but yeah, I do appreciate that it's available. It may not be easy, but it is indeed available. So what I'm going to do first is, like I said, remind myself of the options that I have for reading in data with Pandas. It can take a variety of formats. If you have something hierarchical like JSON, that's going to be awkward because it's not meant to be in a tabular format, But it can be manipulated if need be. So first I'm going to read it in, and I'm going to use... Okay. There's a chance when I LS'd it didn't... Oh. This is what I get for doing something right before. Timeout. I moved directories for the sake of clarity on GitHub without restarting my kernel. So this is a great way to show you that this is what's going on. I'm locally hosting this notebook, and we'll see if it wants to come back. Yep, I know it's down. All right. Oh, it's like somebody looking in your laundry. Okay, so I'm already working on my virtual environment, and yeah, from the terminal I can run Jupyter Notebook. Yep. Okay. This is a thing I did. Now we're back on track. See, this is a demonstration of how helpful Pandas is. Okay. Now I'm back in the directory with my data. And one of the arguments that I can pass is that I want a column of a particular, I want a column to be of a particular type. So first I should show you what that is. What's powerful about pandas and what a lot of people don't like about it at first is that pandas has its own object that it cares about called a data frame. And there are like methods you can expect for that data frame. When I spoke to the guy who developed a transit app, he wrote 500 lines of Python, effectively reproducing what Pandas does in his own way because that's what he wanted to do. So, you know, there is no right or wrong way, but if you can take the time to work with Pandas, it's really extensible. It's really it's powerful too. For example, like I wouldn't want to write functions to expect all of the ways that data can be represented when I read it in. It's already done for me. It's rendered strangely. And then we'll see if I successfully took this subset. Yeah. So you may see when I use this method called info, I got a name for all of the columns in it, the number of rows in the entire data frame, and the type for each one of the columns. And so I can compare based on the total rows I should expect, you know, whether I have a lot of missing data. As it turns out, this is pretty complete data, but there's actually too much of it. I'm going to skip the boring part where I figure out every one of the columns that I don't actually want to use and just pull this subset. This is a little cryptic, but I'll make it easier and say when the United States offers you income data, we have it by our states and then a postal code. And then it breaks down everybody in that postal code by their income tier. So, you know, some people are making over $250,000 a year. Some people are making less than $25,000 a year. And it assigns each one of the people in those brackets a number. Then it tells you how many people in that area have that income. And then it gives you the total amount of money all of those people made together. I don't know why, but I mean, it is a cool artifact because that way I get a sense of, rather than a mean from which the distribution could look like anything, I can get a sense of whether there are a lot of wealthy people in a zip code so that I can move there and be their friend. So one of the ways that you can tell pandas, well, I just want like a subset of the columns, is to explicitly name those columns. And it's very intuitive, right? It's just saying like this new thing I'm calling the subset is these columns from the original. And I should back up a little bit to say that the reason that I do this is if you run an operation with pandas, let's say I do like, I turn everything in a pandas data frame from an int to a string. It'll do that and show me that, but it actually isn't changing the original data structure. It is, as you can expect from Python, it's being conservative and showing me what it would look like for me to perform that operation. If I do want it to change the underlying data, I just have to pass in place equals true. But that's another way that you can safely explore your data without like mysteriously like assigning things to a variable, forgetting that you assigned it to the variable, and then getting confused about what your workflow was. This is just my preference. When I pull in a data set, I think of that as like holy. That is the original data, and it is the source of truth. And everything I do after that needs to be assigned to something new so that I can keep track of it. Because sometimes I confuse myself. So yes, I pulled in the subset. I have another function named, I used function info and also describe to get a sense. It's very rough, but it's just like your mean, your count, your variance. Once I've done that, I just wanted to show you that this is the syntax you would use for a row subset. These are always like the first things you want to do. You're like, I want some of the rows or some of the columns. Note that slicing works differently in pandas. That 11 is inclusive. So you're getting 6 through 11 rather than 6 through 10. That's kind of a trap that I want to point out. So I also want to rename these. because it turns out, N1 and A00100 is not super helpful. So I've renamed it for myself, and now I'm taking this built-in function to just look at the first few rows. It's just called head, and it tells me, what the headers are and the contents thereof. I look at it and I say, okay, sweet, I'm looking good. Oh, wait, what is this? There's probably nowhere in the US that's supposed to look like that. And as it turns out, there is no 00. It's a placeholder. And I point out the mean at this point because, oops. So I understand at this point that the average population of a given postal code is now 10,000 people. And I'm like, okay, does anybody know what the average population of a city in the Dominican Republic is? No, right? I mean, if you do, I'm impressed. But yeah, I don't have an intuition for what I should be finding. So I'm cruising along. I'm like, yeah, 10,000 people, sure. But that's not actually so. So I want to change this and render those fake zip codes as something called a Nan. And I'm sure, well, probably, yeah, Nan is not unique to Pandas. So I've changed that. And now, instead of a fake zip code that when I'm trying to do operations by zip code, it will no longer appear. So I know that it's there. It's an entry that had existed, but it's not valid for my purposes. And this is me now. I'm going to gloss over some of this. This is just saying, like, I want to drop those Nans for the subsequent analysis, and the real population mean is actually half what I was told it was before I fixed my data. I wanted to take a little bit of a detour here to show you that because I know from the documentation that what they're saying in this is the amount of income is in thousands, inexplicably. Maybe it's because they didn't want to care about the error. I want to multiply it by 1,000 so I see the real number for everybody's income. And when I do that, there are a couple of things I can do. I mean, it's intuitive to just try to perform the mathematical operation, but if you have a function that you want more sophisticated than, say, multiplication, that you want to apply to every row, you can use apply here. You can use an anonymous function, write your own custom thing that you want to perform on every row. But in the case of something that can be done with simple multiplication, it's good to use what's built in because I guess you already saw the output. Significantly faster to perform that math because apply is running in Python, which is significantly slower, and Pandas, while it's its own thing, is built on NumPy, and that runs in C, and it's significantly faster. So that was a segue, and now we're back into the data analysis. Just to be sure nothing else creepy is happening, I use tail and head. I'm doing this constantly. If you're in Unix, do you find you like PW, maybe you don't have to do the working directory, but I ls constantly. I get status constantly, just to make sure that I'm not doing something funky. So that's sort of my method for data analysis as well. This way, and again, it's just like writing English. I just want to make a new column now where I have generated the average person's income then for a given area. Gloss over that. And so now I have just the zip code, a population, and each one of those people's, the average income there. But that's actually not good enough. Because a zip code for me is like not something useful to talk to somebody about. Like I went to my buddy and I was like, hey, you will never guess what 97215 makes. Like he's not going to say, wow, I can't wait. Like I want to talk to him about like Oregon or like New York. So I want to reintroduce the names of the states, which I didn't tell you about. When I performed this aggregate function, it was expecting to deal with numbers, of course. I performed an aggregate function to find a mean, and it dropped the strings signifying the states out of it, because it is incoherent to merge or to group California and Oregon. Trust me. So I want to perform a merge. How many people here use SQL? SQL. Yeah, it's like a join in SQL. There's a nitpicking difference I won't go into because it's out of scope for this, but I'm doing what is very much like a join. So I'm going to take, now I want just the unique relationship between a zip code and its state, so I do that. Now I have it. 0 is not going to matter because it's a Nan in my income data set. I'm making a new one, kind of glossing over it, and aha, now I have the state where a given zip code is. Now I want to organize it in descending value by income. And then this starts getting hairy because I think this is very cool. It is not PEP 8 compliant. In most of my notebooks, I have 150 characters because sometimes I get lazy and chain methods and don't make it look nice. But that's something I think is super powerful about Pandas is you can, when you chain these methods, you're doing a lot of fairly what would be complicated operations like English, like your natural language. So it turns out the thing called DC has the highest average income. As you may well know, DC is it's being counted as a state for this data set, but it's where the US capital is. I'm not sure, why they're all so much richer. That's how, actually, I guess I do know why they're all so much richer. Anyway, so, these are all different areas of the US that I can look at, and yeah, that's pretty cool. This is where the Silicon Valley is, so that's why it's high up there, I guess. Then you go down. Yeah, I'm not sure what's going on with North Dakota. I don't know. Yeah, I don't know. Oregon is way down here. I actually should have made a new column for rank. But anyway. Okay. Yeah, that's another method chaining I can do. But I made a new variable describing this huge mess that I just wrote because I just want to look at the top 5 states. And it's as easy as just appending .plot to this to get just a quick visualization of my data. And I could talk more about plotting, but I may not have time. So I'm going to move on to the next data set, and I can revisit if I can. Actually, 10 minutes? 8 minutes. Nice. Okay. So here's a new data set. Nope, this is the one that's supposed to complain. I was interested in tourism data. So the first thing I did was exactly this. You're seeing my first workflow, and I thought, okay, great, a traceback right out of the gate. This is looking good. So I said, okay, well, what's up with this file? And I'm able to, without leaving the notebook, read it, just use a bash command within it to just look at what the problem is. And this is an extremely common problem with government data, is the first several rows, rather than being headers, are like meta information. And yeah, you can tell engineers aren't doing this, right? So yeah, not into it. So instead, I can, in one swoop, specify here that I just want to skip the first 4 rows. Then when I do that, okay, it didn't complain about what it got. And I can see, all right, there are 248 rows. That makes sense. This is country data. I have a pretty good intuition now. But then I look here and it's like, well, for some reason, even though all of these columns exist in this official World Organization data set, nothing's there. And that's no good. So I'm just going to be lazy and say, all right, I want to make a new variable where I drop any column for which every value is Nan. And then this is what I wind up with. A nice clean subset where, not every single value is present, but it's at least useful. Can I do the same thing I did where, I figured out earlier today that earlier that I didn't want that these columns, restructure it, and again, yeah, there are a lot of Nans and it's kind of noisy. I'm not into that, but It's a compromise you have to make with government data. Now I have the names, code, the variables, and these values are strangely represented here because they are large, but it won't be so bad later when I fix it. Then I'm going to perform a thing that this is the exciting thing I wanted to show you, which is melted. This is where I get super excited, because doing this kind of work is like solving a puzzle. And over time, as soon as I see a data set, it's like this horrible, large, complicated mess, and I already have an intuition about what's wrong with it. So the way that Pandas wants to deal with your data, even the way I now want to deal with data, is that you would have header country, header year, and then the year would have the values, 68 through whatever. But in this original data set, it was country, code, and then 96, 97, 98, 99, blah, blah, blah. And that's not, Pandas doesn't see each individual year as of the same class of like country, right? Is that intuitive? Like 1996 is not the same thing as country. Year is, yeah. So you can, using Pandas, say, I want to, if this is a lot like a pivot table, if you use pivot tables in Excel, you can say like, this is how my data is organized now. I don't like that. I want you to rotate it this way. So that's what I do. It's just called melt. And you can say, all right, I want to melt this data frame, and these are the variables that I want to keep in place. I only want to keep country name and country code in place. Everything else needs to be rotated. You'd think like 90 degrees. And that is indeed what happened. So now I have a new data set where variable is 95, value is these awful numbers. I'm renaming the columns to make it easier for me, and I wanted to cut to the chase for y'all today. I'm just interested in what tourism to the Dominican Republic has looked like. So here you all are. And again, this is the thing with data, right? Like, this is sort of the final product, but you look at it and you don't say like, oh wow, that's fun, absolutely, yeah, 2004. Like, that's not helpful. So instead, I make a plot. Just dot plot. This is the Dominican Republic since 1995. Does that seem true to you?
Yes.
Yeah. I will actually follow up out of sheer curiosity with a comparison, against other countries, because we don't know yet. That's why this is exploratory data analysis, actually. This is a perfect example. The point of exploratory data analysis is to run quickly through your data and say, hey, this looks like a cool thing, but I don't know yet whether it's statistically significant, whether all tourism ever looks like this. And following this, I am now equipped with a story that I can use to develop more sophisticated questions about what the data could be doing. And that is for another notebook. That is all. All right. 2 minutes. Very quickly, I want to say that I am trying to speak Spanish, use it, whatever. I have written bilingual documentation, a bilingual README for this, just in case. And I've included links to bilingual resources. Because, for example, when I've been trying to do something in Spanish, like read a novel, I've realized that it's been useful for me to have the both languages in the same place, in case something is incoherent. So maybe I'm just incoherent. Does anybody have any questions about that? Any questions about, data, data, yeah.
What source would you recommend to study data analysis?
Yeah, I had previously included references, but they were a little out of date. And now I'm using Python 3, so the book I'm about to recommend to you, I think, hasn't been updated, but Python for data analysis. I will add to my documentation a bunch of links for things that I have found useful. If somebody ran up to me right now and said, if you can't tell me the top 5 things you need for data analysis, we're both going to die, I would say Python for Data Analysis by Wes McKinney, who wrote Pandas. Python for Data Science by Jake Vanderplas, this Jupyter documentation, Think Stats by Alan Downey, and that was for dramatic effect. I have one up my sleeve. The 538 website, which is a great blog about statistical approaches. I'll link all of those and then give a better treatment of it in like a blog post soon.
There is just a comment. There is a really good blog about data science in Spanish. It's Fibonacci. Two people from Spain, Pico and Juan. Fibonacci.
Oh, clever.
Spanish, very good.
Yeah, it's in Spanish and it's very good.
Okay, I'm going to keep that in mind. Thank you so much. You had a question?
Yeah. Is there a skip rows method or in a data frame that would skip from the bottom as well? Like if you had so if someone put that information in a comment at the top, like I think in Python 2.7, if you read a JSON file that has a comment in the first and last lines, the guy have to parse that separately outside of my JSON reading it in. I wouldn't read a JSON file into a data frame, but
Right.
I didn't know about skip rows. I thought it was really cool.
Let's
I
see.
know I can Google it too, but I've looked it up a bunch of times.
Interesting. This should show you right here. Do we have any other questions while I try to figure it out? Yes. Yeah, skip rows says it takes list like or integer. So yeah, you can probably do the negative and then the colon. Yeah. Any other? I love this. All right. Also, yeah, feel free to talk to me later in the conference. I can talk about Python and data forever. All right. Thanks.